Okay. Gonna see if I can get through these chapter 6. Oh well, let me do a little intro here. Hello everybody, welcome back to the channel. Hope you're having a wonderful evening so far. Today is Sunday, November 23rd, 2025. We're going to be jumping back into C Programming, a Modern Approach, second edition by K.N. King. This is chapter 6, or the end of chapter 6 exercises. I'm going to try to see if I can get through these in an hour. Yeah, it's going to be difficult, to say the least, to see if we can get through them all. But I think we can do it. Let's go ahead and give it a go. Yo, what's going on? We got some people in here. Elite Z, Eduardo, how's it going? Welcome in. Got some people already rolling in here for the night. How's it going, everybody? Get some tunes for tonight, and we can get rolling. Let's see here. All right. All right, let's get rolling here. All right, what does the following output produce for the program fragment produce, right? So we have I is equal to 1, while I is less than or equal to 1 or 128. Less than or equal to 128, we're going to print the number and then multiply it by 2. So we'll just I don't want to waste time, but we'll write it out. Let's go ahead and int main void here. We're going to go ahead and open this up. We're going to have int I equal to 1. We're going to go while I is less than or equal to 128. What are we going to do? We're going to print f, and we're going to insert the value of I here, right? And then we're going to take I and multiply it by 2 and move on from there. And we'll return 0. Cool. So what this is going to produce, we'll say the expected output, right? It's going to produce 1, 2, 4, 8, 16, 32, 64, and then 128, and then stop. So if we go ahead and run this, let's see if I can go back to our compile statement here. We'll do over here, chapter 6, exercise 1. This is chapter 6, exercise 1. Okay, that compiled, and let's go / chapter 6 exercise 1 exe 1 2 3 4 1 2 4 8 16 32 128, but without the commas, right? Sorry, commas are just my beautification of the list output. So let's just do some quotes here. Nice. It's gonna also print 1 space at the end there, right? C-Lang is a tool for tests like V-Test or J-Test in JavaScript ecosystem. Nice. Okay, cool. I just want to really quickly rename this to, this is going to be just for my consistency, chapter 6, like that. Yeah. Oh. Bring that back. Chapter 6. chapter 6, like that. Okay, and then we're going to rename this guy chapter 6. Wait 1 second. Can I rename all these? No. I mean, I bet you there's probably a way to do it, you know, programmers and all. Chapter 6, rename. Hold on, I was trying to make these names consistent with our formatting so far. Give me a second, y'all. Chapter 6. Jesus, a lot of these suckers. Last one. Okay. Chapter 6, exercise 1. Chapter 6, exercise 2. Okay, cool. Let's get into this one now. Okay, next up. What is the output? What output does the following program fragment produce? Cool. So we're going to set this up. Include the standard io.h header files. We're going to have int main with no parameters, and we're going to have an int variable I equal to 9,384. We're then going to do the following: printf with a insertion of the variable I, and then we're going to decrement by a divisor of 10 I, and then we will do that while I is greater than 0. So we will perform an action no matter what the value of I is on the first pass, but then reduce it down until we get this condition. And if we do not hit this, then we will break out, right? So this will, let's just GCC chapter 6, exercise 2, chapter 6, exercise 2, chapter 6, that. And then we'll do / chapter 6 exercise 2. I need to probably learn. I've been trying to learn more about makefiles to see if we could get that a little bit better, but just make our compiling a little bit easier on us. But I'm not sure about all this nested file structure for makefiles and stuff. Hey Sylvia, welcome back in. How's it going? You've been in here quite a few times the past couple nights. Thanks so much for joining me all the time. Appreciate everybody here. If you could drop a like on the stream. I uploaded some shorts today up to the channel. Just chopped up the had the idea to chop up the readings into shorts. Maybe I could do the whole reading of the chapters into shorts, like short form reading content. I don't know, it's kind of funny. But yeah, it's kind of cool. Okay, so let's do a comment here. Expected output. And let's go ahead and so if we have 9384, we're going to print I no matter what. So we're going to print 9384. And then we're going to divide it by 10, which basically just drops off the last digit. Right, so we're going to print 938. And then in the next run, we're going to drop off the 8 and print 93 and then print 9. And that reflects right here, perfect. Nice. That takes care of number 2. All right, let's keep pushing here. Number 3. I'm going to try to move through these a little bit quicker today. See if we can try to get these done in like an hour. What output does the following for statement produce? Okay, so we have 4 So let's set this up. Include the standard IO. Ooh, no, whoops, sorry. The standard IO.h header file. And let's go ahead and create a main function. Have no parameters in the main function. Open up the main function and let's declare or let's write a for loop where we have int I equal to 5, j is equal to 1. We can initialize the variable or define it or whatever to a type inside the for loop with C99 and above, whereas j is equal to I less than 1. So j lags by 1. We have two conditions, I greater than 0 separated by a comma for j greater than 0. So these two conditions are met with probably some short circuiting that or maybe not, because there is no or statement. It's not an expression. So I wonder if both of these have to be met, kind of like an and, right? So if we then reduce I less than 1 here and then set j again to the lagging of I less than 1, separated by the comma operator. And so if we open this up we have a single block, so we don't need to specify the braces. We can just do %d, insert that, and then put in the I variable like such. So let's think about this. So I is going to be 5 to start. So on loop 1, I is equal to 5, j is equal to 4. Right? The conditions are passed, right? So we're going to go ahead and print this. So what happens is I gets printed. So I prints. So in order to say here, right? I prints. So we'll say prints the I variable of 5, right? Now, on loop 2, right, I drops down, well, actually, this is less, which doesn't matter, because this is what happens at the end of the statement, technically, to update after our statements, right? So the less is it doesn't really matter with less or less on the right or left within the for statement, because this is basically these two updaters are at the end of our statements. I think that's the relationship that has. So if we drop on the second statement I to 4, j would then equal to 3, and we would print quote. We would print the I variable, right? On loop 3, I would then, I would drop to 3 if we follow that same principle, and j would still lag behind at 2. All of our conditions are still met here, so we would print I at 3. On loop 4, right, I would decrement down to 2, whereas j would go to 1. We would still meet our conditions here and print the I variable. Now here on loop 5 is where I would drop to 1 and j would drop to 0, thus making this not true. Right? So I think that's all that would happen, so that the expected output would be quote 5, 4, 3, 2, and this actually would not print. All right, so this would be 4, 3, 2, 1 with a space. So let's compile this. Rational comparison used here. Okay, so it doesn't like our... So we get... am I missing something here? Warning, relational comparison result unused. Relational comparison result left unused. Okay, so let's go ahead and relational comparison error. The only trick that worked was making a useless variable inside the for condition. But that would be useless and just take up space other fixes. The first part of a for is the initialization part, not the condition. Because he's abstracting out. Yeah, so he's missing that guy. I have this section, and this section. Format of C for loop, for initializer condition, end of for loop, expression, end of each loop expression. Any expressions can be empty at the for condition needed, so this is not really answering me here. Is it really like, is it this? No. I don't need to also say int here for this variable. I thought it's kind of use of unidentified variable I. So instead, it's not that. I don't want to go to the AI. I want to try to figure out if we can find an answer with actually looking stuff up here. In general, so I have a semicolon here for these two statements. So if I were to get rid of this J, okay, so it is that. So it doesn't like to have this J here. But then this will print all of the values. So maybe I need to do I need to like link these into as an expression? Right? There we go, that compiled. Five, four, three, two, yeah. Oh shoot, sorry. 5, 4, 3. Oop, what am I doing? Interesting. So it needs an and here in order to perform this comma operation. Okay, now let's take this now that we understand that. Let's say I was getting an error, a relational error with this statement, and I fixed it by using the and in the expression eval, right? You're absolutely right that switching the comma operator to the and fixes the error. Here's why. The problem is the use of the comma operator in the middle expression. The loop condition in a for loop, init expression commas are fine. Increment expression commas are fine. The condition expression must evaluate to a boolean or true or false. You wrote this. This is a comma operator which evaluates to this. Discards the result, evaluates J, returns the final result. So the entire condition becomes just this. But the part is that part is legal and C standard, but you get an error because the first part of your for loop is always wrong. Minus I. That's not a valid standalone expression in the increment station? No, I have minus I. This is not and, this is a comma operator. Comma operator evaluates this as true, discards it, then evaluates this, becomes a loop condition. So then why am I getting errors here? Doesn't make much sense. Pointing at this. Oh, but it generated a warning. It wasn't a compilation error. I get this wrong. Okay, so maybe I'm being stupid. Sorry, you guys. I didn't understand or not understanding the difference between the warnings and actually errors. It's not an error, it's a warning. It's saying, oh, you might not like this, or warning you, but it still went through, right? So now if we still compile, it still happens. Ah, my bad. I thought this was a error. It was just a warning flag, so it still worked. Dang it. So that was a noob move. Well, now since we've gone through that mental exercise, now we understand that be a little bit more careful about reading these messages, because warning doesn't mean failure. It just means that you might have something wrong if you're not. It's just giving you a little bit of like something might be issued here, but if you want it this way, then so be it. Okay. So I'll say the I greater than 0 is discarded after evaluation, and the loop conditional expression relies upon the J greater than 0 result. Right. All right, let's move on. Hey, new app, how's it going? Hey, Lancy. I appreciate you for coming in. What's going on, your doctor? Thanks for coming in. Hey, Prism, how's it going? Welcome. Great to hear from you guys again. John, did you change your name? Is that you, John? Hey, Tim, how's it going? Any stock buys before the new week? Dude, I wish I'm running out of cash, man. I I've been buying I've because I've been buying the stocks, dude. I've been eating up this dip. I'm really a proponent of the. I don't know, man. You have to. There's something about the market when everybody and their mom is calling for a bubble crash, even people that have no idea what an actual bubble is. They're just kind of repeating things on the internet, and market makers and big money, they'll eat that up, and they'll eat up that psychological fear all day long and continue to push it higher on and just kind of. I don't know. I think it's all. They're just. It's a. I think it's a scam to just get people to sell and get out, and it's just. Um, I mean, the earnings are there, dude. Like the numbers don't lie. Like we dropped like 10%, 15% on like Palantir with like one of the best earnings statements like the stock market's ever seen from a company like that. Um, it just proved people like wrong basically, and I think a lot of people got upset. Um, Same with Nvidia too. Like it just is proving people wrong every single time. Like saying, oh, it's a like the demands. If demand is there, dude. Like the demand is the demand. Like I don't know. The CEOs aren't lying to you. I don't think. Like they might be like obviously inflating things maybe a little bit, but I don't know. It's okay. Let's keep pushing. Sorry, can't we can't talk about stocks here. We're trying to get through this in under an hour here. Okay, four. Which one of the following statements is not equivalent to the other two? Assuming that we. Oh, I'm Tim. I think MU is the buy here still. On this pullback, this huge pullback that they're experiencing, if they come back any further, it's green lights. I mean, RAM is going to be like memory. People need memory is just going to keep going, man. So MU, I think is the sleeper that people aren't. It moves fast, man. The volatility on MU is nuts. So if you can hold in there and get into some good prices on this dip here, I think it's we'll see. Okay, four. Which of the following statements is not equivalent to the other two, assuming that the loop bodies are the same? Okay, so interesting, right? In all of these statements, we have the initialization of the variable. In all of the statements, we have an expression, but not in all of these statements do we have a third expression, or like a. Sorry, let me rephrase that. All these statements have a conditional expression, but not all these statements have an updater expression. This one has the updater expression within the actual for loop conditional evaluation. So interesting. A little kind of a tricky. So these do not matter. These are going to update. These are the same thing, I'm pretty sure. These are going to update the value no matter what at the end of the statements of the loop body, right? This expression takes place as the last value or the last line in our statements, from my understanding. Now, whether you update right then and there or you update at the next like sequence break or whatever it is, doesn't really matter because you're going to update whenever if you update then, or that the update's going to take place before you get back into the next iteration of the for loop, right? So you're going to hit that sequence break for this guy here. Whereas if you were to update it right away on that line at the end of the body. Now in this guy, right, we are actually we're doing I plus plus, so we're incrementing I at the next sequence break, which could be the same thing as this, right? Well, this will do an evaluation of I, but then, this one's tricky. This one's tricky. let me just go here to this function. Let me just copy it here. Grab it, this. Let's go I equals to 0. Let's get rid of this guy here. I is less than 10. Then I plus plus. Right? We're going to print I here. So if we run this one, for exercise 4, oh my bad. Oh, whoops, sorry. I'm trolling you guys. Chapter 6, exercise 4. Ah, shoot. Alright, this will print 0 up to 9. Okay. Now, what happens if we comment this out, duplicate it down, uncomment this, and do the plus plus I here, and run this? Zero through 9. Nothing happens. Different. Okay? So now, if we copy this one down and have the initialization take place, but have the updater happen within the conditional expression post-fix, right? So now what happens with this statement? An error. Oh. Yes, because we need this. This includes... Ah, okay. So this is updating I. Oh, I get it. I get it, right? Remember, we're doing think about in Python how we have to evaluate this expression to be true, or even in C, doesn't matter. We have to evaluate this expression to be true to actually perform any actions or statements within this for loop body, right? So by evaluating this, we immediately make I increase. And then I guess that is a sequence break in and of itself. And I, when we move into the statements of the for body, is already one step higher. So when I is 9, this evaluates to true. And then it also increases to 10 and prints 10, even though it gets past our conditional. So it actually kind of like breaks our conditional essentially and really causes this kind of funny bug. So line C, we'll say this, right? C is the odd statement out. It produces before entering the for statement, the conditional expression is evaluated. Thus causing an increase in I before entering. This also I to lead. This causes to lead by 1. Conditional check and post increment. In this condition, this means to compare the old value with I of 10. See body runs. The condition is evaluated before entering, and because it uses plus increments before printing. Cool. Nice. Let's keep it pushing here. Let's rename this boy. Chapter 6. Okay, number 6 or 5. Number 5 here. Let's keep pushing. Hey, Blasto, how's it going? Well, it's a bug if you didn't intend it to be that way. It's all about intent and whatever it is. What's the word for it? Perspective? No, I don't know. I guess intent, for lack of a better word. Okay, cool. Which one of the following statements is not equivalent to the other two, assuming that the loop bodies are the same? Okay, so which one of the following statements is not equivalent to the other, assuming the two loop bodies are the same? While I is less than 10, perform some actions. 4. Well, this one's easy. It's going to be the do while, right? The do while will perform one action no matter what, and then do this evaluation. Whereas these two won't enter the loop body without actually evaluating this to true at first. So let's go ahead and I'll do C is the odd statement out. The do while loop will perform an initial perform the statements in the loop body at least, is that at least one word or 2 words? What, 2 words? At least one time, and then evaluate the conditional expression to decide whether or not to continue the loop. We're going to loop again. Let's continue the loop. A singular for or while statement will not perform the actions in the loop body unless the conditional expression is met first. Oh, let's get some feedback on that guy. Unlike a while and for loops, when do while loop, the loop body runs a contrast evaluating whether or not this loop is running. Let me just do this guy here. C is the odd statement. Now the do while loop will perform the statements in the loop body at least one time. Did I spell anything wrong here? I think I did. Statement. Statement and singular. Singular. And evaluate. Okay. Cool. Let's push it. Keep chugging. Number 5 here. No, that is 5. 6. Making good time here, boys. All right, let's keep pushing. Translate the program fragment from exercise 1 into a single for statement. Okay. So let's go include the standard io.h header file. Let's go int main void. Open this up. We're going to do for int I. We'll set this equal to 1. I less than or equal to 128. I multiply equal by 2. We're going to printf the value of I itself and insert that there. So that'll take care of that, I think. Now we might be able to even abstract this out here and then do this here. We want to be really crazy with it. But I don't think it's really necessary. It probably makes things a little bit more confusing. All right, let's take a peek at this guy. Exercise 6-6. Oh, I did that. I'm not supposed to do that. Nice. 1, 2, 4, 8, 16, 32, 64, 128. Perfect. That is number 6. Number 7. Let's keep it rolling. We're just going to show that we're learning this. Like we're able to kind of move a little bit quicker on these exercises this go around. Yeah, I mean these aren't really that difficult, but it's good. It's good to kind of prove that we can at least are following up to this point, right? Just for some sanity checks. Okay. So for 6 or 7 here, we're going to translate exercise 2 into a for statement now. So pretty similar to the previous one. So for, let's declare our variable int I is equal to 9,384. We're going to do this while, oh, this is interesting, right? This is a do. Interesting. This is a do, right? So I wonder, like, do you have to just do a printf out front? Do the action out front? Because the print statement will always evaluate. And then do you need to set I, reduce it by 10 to start? Like this, so you have to do printf and insert the value, right? And then do you need to do the action? Oh, whoops. And then do you need to do the action of divide equal 10 here for I, and then enter the for loop and perform the for loop evaluation here. Like this, right? Is that essentially the same thing as the do while? Because you have to perform the action once, do the decrement down, do the update, because the update will be, we don't want to print out the same number back to back. I mean, we could keep track of a variable as well for the initialization of the actual loop itself, for how many loop a counter, and basically an index tracker. And if it's the first one, print. Right? Hmm. Interesting. Trying to think about like what. Oh. Right, so that would do it right there. But just, do we have, is there any way to make a for loop perform the action well, what about this example that we saw earlier, right? Where the action took the update took place in the condition, and so you printed out the next value. But you don't want to print out the next value. You don't want it to lead by 1 because we want to actually get a print of the initial value. And what about this? Let's print the initial value. Get rid of this guy. Do I divided by equals 10 here? No, because then that's the kind of unique thing that you can do with plus plus and minus minus is you have prefix and postfix, whereas this just performs this action at this place in time. Well, what about this? What if we just say I divided by 10 itself is greater than 0? We can put I back into here, remove this statement here. Now we'll print out, well, this will be true for the next value, and then we'll perform it on the lagging value. Let's freaking go. Oh no, we need one more. Oh, crap. Right, because it's taking the 93 And then what happens if you just print f? Well, we can't get access to I don't think here, right? Because it's localized to this scope. Yeah. So if we take I outside here, now we can get access to it. No. Oh, it's outside of my main function. So that'll give me the value, right? Trying to convert this for this do while statement into a single for loop. I am trying to use some clever logic to print the initial, but also the lagger at the end. Do I need the final print f to get the final 9? You can do it in a single for without the final printf, but only if you let the loop print before dividing instead of after. Right now, your for loop prints the current value of I each iteration before dividing by 10. That means the last digit never gets printed. So if we say declare it out here, we say while I is greater than 0, we will reduce it by 10. Oh, really? That's it? What? Am I dumb? Let's think. Oh, I guess I am dumb. Why wasn't I getting that? Let's think back. Let's not move on yet, but why wasn't I able to understand or see? I think I was just maybe thinking about it too hard. It's actually a lot more simple than I thought. Because the for loop let's ask here, why wasn't I able to see this answer? I was caught up on the idea of the do while needing to perform an action on iter 0 no matter what condition, right? I guess because the condition is met for this specific number, it is true. But what about if the number is 0? The do while property is broken, no? You're eventually anchored on a do while runs at least once, and a for/while might not. Because of that, you kept thinking your for loop must somehow replicate always runs once behavior. That tunnel vision made you force unnecessary complexity. But in this specific problem, the condition is already true on the first iteration for any number that is greater than or equal to 10. So the loop does naturally run. That's the key unblocker. What about if I is equal to 0? You're 100% that if I is equal to 0, the version prints nothing, while your do while would print once with an output. So yes, the do while always executes once behavior is broken for the for loop version. Why this doesn't matter for the original number. If you want it to be 100% equivalent, you can make the perfect structural equivalent by doing this. Oh god. So you declare the variable and you keep track of a first. And then you short circuit the first by saying it first, right, is 1, or if first is non-zero, or this is true, non-zero, right? Wait, no, for 0 is true, 1 is false. So these would evaluate to 0, right? So the first is 0, which it's not. First is 1. First equals 1 guarantees 1 execution do while semantics. So this evaluates to if any of these values are non-zero, right? So this always performs a run no matter what. Okay, yeah. The runs if any left or right val is non-zero. So setting first to 1 guarantees a run at iter 0. The logical OR in C works as this, any non-zero values. So when you do this, it always runs for that first. So to make it perfect, we'd have to do for int 9384 and then set first, or sorry, this is I equal to 9384 and then first equals to 1. We would say if first or I greater than 0, we're going to I divided equal by 10, right? And then we set first to 0. Oh, okay, right. So you have to set first equal to 0 on the update after the first run so that you then only check I from there on out. Now, I guess it wouldn't really... Well, because first is 1, if you don't actually set it to 0, this will always run even if I gets to 0 and run infinitely. So you have to have this. Okay, that's important, right? And so this would just printf to %d here, space, we insert I. And now this would run and give us the correct answer here. Expected expression. Oh, whoops. There we go. Okay, so let's make a comment here. Say the do while statement always will perform the actions within the loop body once. Then evaluate the conditional expression to decide to right. The do while statement always will perform the actions within the loop body once. and then evaluate the conditional expression. We need to set a first variable to track the first step into the loop to force execution. Then set first to 0 to only evaluate over the lifespan, evaluate I greater than 0. Cool. We need to set a first, quote, first variable equal to 1 to track the first step into the loop to force execution. Then set first equal to 0 to only evaluate the this conditional. Cool. Yeah, exactly, Blasto. The first one has to print the first value. So it would work for this specific example, the one you gave, the int I 9384 I greater than 0 printf, right? Oh, but then you have the division taking place in the printf. So would that work as well? Let's see. So if we get rid of first here, if we get rid of first here, get rid of this here, get rid of this here, and get rid of this here, and do this here, do we still get the same logic? No, so that prints that 0. Yeah, interesting. Right. Let me see this one. This prints the 0, right? Okay, cool. Wait, why didn't that work before then? Nine three eight four greater than 0 print on. Oh, right, because that was our first one. But it doesn't work with this. But it doesn't work with the 0 as I in it. So it doesn't behave like do while 100%. Correct. Cool. Nice. That actually was really kind of helpful for understanding these a lot more. Like really taking the time to think about it and print out the examples and go over it here. Nice. Okay, let's keep pushing here. We're almost there with these ones. We got to 14. Okay. And we're at hour and 5. Dang it. My goal is to get done in an hour. Oh well. Okay, number 8. What does the output for the following for statement produce? For I is equal to 10. And we're going to do the performance while I is greater than or equal to 1. We're going to reduce I by 2. And then we increase I after the fact. Oh, interesting. This one's cool. So include the standard IO.h header file. Let's go int main void. Let's open this up. We're going to have for int I equals to 10, I greater than or equal to 1, and then I divided equals by 2. We're going to call printf, and we're going to insert the value of I in there, but we're going to plus plus here, right? So in this guy, let's think. So on the I is equal to 10. So on the first pass, we're going to print the value of I and then increase it. Right, so I goes to 11, then gets floored by 2. Right? So I would equal to 5 then, still. We go to 5.5 and then go to 5. And then if we, then we're coming back through, so I is equal to 5. So in the first time we would print, so the expected output here, let's do a little comment. Right? It's going to be 10, 5. Okay, hold on. So I is equal to 5. That passes this, then goes through, prints 5. I increases to 6, comes back in through the loop. That passes as true. Wait, hold on. We enter as 10. We print 10. We increase to 11. We divide by 2. Floor by 2. Divide and floor by 2. That gives us 5. We enter. We print 5. We increase to 6. We divide and floor by 2. So that goes to 3. We print 3. We increase to 4. We divide by 2. We print 2. We increase to 3. We divide and floor. We're at 2. We print 2. We increase to 3. We divide by 2. 1.5, that's floored to 1. We're greater than or equal to 1, so we print 1. We increase to 2. We divide by 2, which goes to 1. Which goes to 1. We increase to 2. Does this not run infinitely? No. Let me grab a little piece of paper. Let's not, or let's do it on the whiteboard, I guess. We don't need to go to chat for this one. We can work through this one here. Okay, so let's think about this. Right? So I is 10. Pass is true. So this is what the print is going to be. Okay? So I is 10. We print 10. I increases to 11. And then we divide and floor by 2. So I would become 5. We print 5. We increase to 6. We divide, floor by 2. So I becomes 3. We print 3. We increase to 4. We divide and floor by 2. We print 2. We increase to 3. We divide and floor by 2. We print 1. Increase to 2. print 1, and that continues now. Start off at 10. We print 10. We increase to 11. We divide by 2. Just a 5. Let's run it. Let's see what happens. Oh, my bad. It does go infinitely. I was right. Wow. Now, did I copy this over right? Int I greater than or equal to 1, I less than or equal to 2, print f the value, infinite. Jeez Louise. Right? All right, let's go get this check here. This does become an infinite loop, and the reason is subtle, but it's important. Post-incrementation happens after the value is used, and so it's self-repairing. Nice. Cool. All right, next up. Number 9. Translate the for statement of exercise 8 into an equivalent while statement. You will need one statement in addition to the while loop itself. Okay, let's copy this over into here. So int main void. So we're going to have int I equal to 10. We're going to say while I less than or greater than or equal to 1, right, we're going to perform the following action. And then we're going to do I, well, that we can do I++ there. And then if we do I divided equal by 2. That should give us the same output, I believe. My bad. Just gotta rename this guy. Whoops. Yep, nice. Cool. And then let's check this. Convert it to wow. Boom! Look at us rolling. Look at us. Who would have thought? Not me. All right, let's keep pushing. I'm feeling good. Liking the loops in C so far. Okay. Show how to replace a continue statement by an equivalent go to statement. Okay, so let's go ahead and include the standard io.h header file, int main void, and then let's go int I is equal to 10, not 1, 10. Let's go while I greater than 0. Let's open this up. Printf so we printf and we'll insert I here, right? And we'll do I, yeah, and then we'll do I plus plus. Could do that here, right? So then we would have to say replace a continue statement with go to. Hey, who is that? Hey, Bass Golfer, thanks so much for the follow. I appreciate you. I appreciate that so much. Thanks so much for the support tonight. If you guys are enjoying the stream, if you guys could leave a like, appreciate you so much for hanging out with me. Hey, Shadow Crush. Oh, what happened to my YouTube chat? What the heck? Oh, weird. Hey, what's up, Shadow Crush YouTube? Appreciate you coming in. Okay. So instead of saying if I modulo 2 is equal to 0, right, meaning that it's even, we're going to go to how does this work again? Let's go check here. Go to done, which just jumps to the end of the loop. Okay, so go to print is odd. We'll make a statement here that says even printf quote I is like this. Go to even. So you don't do a colon. Okay, you say go to even. So if I is you go to even, you print this. Else you print this. But this print is going to happen no matter what. This breaks out of the loop though. So if it's even, if the number is even, I mean, I'm trying to think of like an actual practical use of using this. It's not just like, so else, I mean, we could say else here, right? And so else go to odd. And we could say odd here is this printf, right? Something like this. Would that technically work? Compiled. Oh well, it's increasing the number. Um, so we need to decrease the number, right? Which will never end. 10 is even, 9 is odd, 8 is even, 7 is odd, 6 is even, 5 is odd, 4 is even, 3 is odd, 2 is even, 1 is odd. Nice. All right. A simple example of use of goto. Kinda silly and useless, but trying to practice. Let's get some feedback here. Your example does compile and run, but there are two important things to understand. Your even and odd labels both run on every iteration because they appear after the if else, if not inside them. Because of that, you actually print both messages in every loop. Oh, I do? What your code actually does? If I is even jumps to even, prints then falls into the odd, then prints it again. Because I minus minus happened. Oh. Okay, so that's actually just, we gotta, even though it's working visually, it's actually not working. So the right statement would be to say, while, if, right here, go to even, else go to odd, and then but it's instead of the continue statement. Right, I'm trying to replace continue with this problem. Right. So loop top. So you would go to the loop top, then you would loop end. So you create your own loop here. That's wild. Right. Interesting. So it's not like printf continue. So let's I guess we could do continue here. I mean, we're not supposed to, I don't know if we're not supposed to use the continue in this problem, right? It says to replace it with the goto. That's like if we want to go back to the beginning of the loop, right? Can you do this? So could you say just go to start? Very close. You place start outside the while, but got jumped back in the middle of the loop body. Loop can just check only once and you see inside the loop because you never exit through the loop body of the loop. Right? Into your loop, right? You never register, but you never return the bottom. So it's like I want to continue the loop by using a go-to statement to get back to the start. I am wanting to continue the loop while but keeping a loop keyword. So loop start. Oh, okay. So if you would put the loop start within, right? So that runs on forever because the condition is never evaluated again, right? Right, because the condition is never evaluated again. So if you don't go to start on the odd, oh, because you would need to hit the odd. So why does this work? Why does this work then? The label inside, the C jumps go to a label inside the same block where your start label is inside the wall body, and you go to a start. This works syntactically, but it jumps to the middle of the loop without checking the wall condition again. It's not the same as to continue. So you have your starter. This doesn't make any sense. So if this then go to even, go to odd. Even, you'll do these statements. You go to start. You'll do this statement and go to start. But this will run infinitely, no? Yeah. Because we're never evaluating here, right? Another conditional check. They say if, we'd have to do that here, right? Greater than 0, we'd have to break. And then this would have to go to else if. Oh, sorry. If I is less than or equal to 0, We're gonna break, right? We have to bring the condition. So we need to dupe the condition, unfortunately, to continue the evaluations. That's the downside of using go-to. So if start is less than, you would go to end, right? Which is basically breaking out of the loop. Or should you go to start, go to start. Oh, interesting. So you could say if start, go to end. Okay, so you could even say you have your start here. You have this. We would say go to end here, else we would do this here, there, and then take this, and do this there. Right? And then we could delete even or odd here. So if we go to end, else in this, print this, and go to start. And so then end, we would have to specify is outside of our loop here, right? Yeah. Oh. Line 23. So start. Oh, they don't even use a while. Oh, they don't even use a while. They just have the start, right? And that takes care of it. And then the end goes here, like so. And then they take this and bring it in here. Just give me a warning here. Interesting, right? So you would have to, you could just not even use the while, right? I have an extra. This opens. So isn't that my function? I have an extra print. There we go. Okay, I think that's it. Yeah, AJ, I think I'm just I was just trying to exactly. You need to have a meaningful loop to actually, utilize the continuous statement. But I'm just trying to chalk together something here that uses it quickly here. But probably could have utilized some more thought into the actual loop itself, what we wanted to do. But I guess this works. Cool. Hey, what's going on, Utam? Appreciate you coming back in tonight. Kals, Minky, thanks for coming in. Hey, AJ1228. Thanks for the follows on Twitch. We got 3 follows on Twitch today. Nice. Look at that. Okay, let's push. We're almost there. We're almost there. What output does the following program fragment produce? So we have sum is equal to 0. We're going to loop over the values of I until we reach a value of 10. If the I is odd or is even, we're going to continue. And then else we're going to increase the sum by 1 by I. So this is just going to sum all odd numbers together. 1, 3, 1, 1, 3, 5, 7, 9. Right? So 4, 9, 16, 25. 25 might be my answer here. Let's try it. Int main void. Let's set up a int sum is equal to 0. And then let's say 4, we're going to loop over the values of I equal to 0. Int I equals to 0. And we're going to go until I becomes 10. And we're going to increase I at each pass of the loop. We're going to open this up and say if the value of I mod 2, right, meaning that this is an even number, we're going to continue. Else we're going to say sum plus equals to I, the odd numbers, and continue on. And then we're going to print f at the very end the value of the sum. Right? Okay, so I think 25 is my guess. We'll see. This is number 11. 11. Oh, we need to change the file name. Typo. Oh, my bad. $20. Dang it. Did I just do my math wrong? Oh. One. If I mod 2, continue. So then if I... Why are we only getting 20? Why are we 5 values less? Ah, come on. Give me a break. Okay. Maybe I'm thinking about this wrong. Is this printing all even numbers? Yeah, it's even numbers. So if I mod 2 continue, what is that saying? If I mod 2, so if it's 1, it's going to continue, meaning that it's true. No, 1 is not true. 1 is false. 0 is true. Zero is considered false. Why do I'm getting this mixed up. I get the conditional and or mixed up with just the Boolean logic of 0 and 1. So conditional and or both have to be non-zero for that to be true. Whereas any value that is 0 is false, 1 is true. Okay, so I need to keep that. That's a huge piece. Okay, so then this statement means that any value that is odd. So odd values will be skipped, right? So this says that if I mod 2, right, is true, then we'll continue on. So the expected output is quote 20. And I'm going to get rid of this one here. Cool. Hey Alex, how's it going? I appreciate you coming in tonight. Welcome. Welcome back. Okay, 12. Following prime testing loop appeared in section 6.4 as an example. For d equals to 2 up until d is less than n. Increase d if the number is even or won't break. This loop isn't very efficient. It's not necessary to divide n by all numbers between 2 and n minus 1 to determine whether it's prime. In fact, we only need to check the divisor up to the square root of n. Modify the loop to take advantage of this fact. Don't try to compute the square root of n. Instead, compare the z squared with n. So we have include the standard io.h header file. We have int main void. Open this up. We have for int d is equal to 2, d less than n, d plus plus. If n mod d is 0, meaning that this value is even, that we're iterating over, we're gonna break. So this wants us to check divisors up to the square root of n. Modify. Don't try to compute the square root of n. Instead, compare d times d with n. If d times d less than n, is that all we have to do? So we take this and run this guy. undeclared identifier n. That's right. So we need to have int n. Let's say 10. Okay, so this doesn't do anything. D times D. Yeah, I think this is it. Prime checking. The basic prime checking loop. You don't actually know if a factor was found, it just breaks. You need a flag if it does break. Okay. Okay, cool. That solves that one. Rewrite the following loop so that its body is empty. Okay, let's try this one. Include the standard .h header file. And let's go int main void. Open this bad boy up. So this body is empty. So we need to... Okay, so this is simple. So for int n is equal to 0, and while m is greater than 0, we need to also declare an m variable. We'll say that m is equal to like 20 here. We'll say 10. And we'll say this, right? Greater than 0, n plus plus. And then we're also going to just divide m by 2 here, right? So this will establish the variables n and m. This will loop until m, as long as m is greater than 0. This will increase n. Okay, I think that this works. Let's get some feedback here. And n is counts the number of iterations. M will be divided by 2 on each iteration. This checks to make sure that m is above 0. It'll increase m by 1 and halves m. The loop body is empty. Nice. I think that's our answer. Hey, AJ. What do you plan on doing with C? Honestly, don't really know yet. I'm hoping that we can get some inspiration from the book as we dive deeper and kind of learn more about what we can do with memory. Honestly, I think I just don't really know the total scope of C and what we can do with it. Like I think like analogy of I would like to build a house, but I don't know how to use a hammer yet. I know how I can swing it, but I haven't been taught how to hit things yet. So hopefully we can get some inspiration on how we can build the house once we learn how to. But maybe that's a bad analogy, right? Because maybe there's a lot more that goes into building a house, like understanding how to read the blueprints, understanding how to cut wood, understanding how to hammer, understanding how to. There's a bunch of different things, I guess. So it's not as singularity as just one action. But yeah, I don't know. All right, cool. I think we are on our last one here, number 14. Cool. Let's go ahead and wrap this one up here. Okay. on this Sunday evening. If you guys are enjoying the stream, could you guys leave a like? It really would help. I'm trying to push up to 4K subs here before the end of November is my goal. If we can try to do that, that'd be awesome. I've been pushing up some shorts, cutting up and remixing our readings of the entire C Programming a Modern Approach book into like shorts as well. So I'm doing minute by minute. So it takes me, my goal is to like do 4 or 5 a day for the next couple of weeks until I can get caught up through all the chapters. So I've been going back through and using the remix tool to cut out minute by minute and upload those as shorts. I have full readings of the entire chapters on my channel. If you guys want to go back and check those out. We're doing the exercises at the end of chapter 6 here, and then tomorrow we'll do the programming projects and then move on to chapter 7. Okay, find the error in the following programming fragment and fix it. So if the number is even, this is easy. It's that right there. That's our problem. This is so simple. This is so easy. I say that now, it's gonna start ramping up quick. I've been given some warning in this book from some people in the comments that towards some of these later chapters, after like 7, 8, 9, the programming projects and exercises really ramp up, and they start getting a little bit more difficult. So we'll say int n is equal to 10. We'll say if n mod 2 is equal to 0. Right, printf, quote, n is even, backslash n. And then what I'm going to do is I'm going to make a little comment here and comment out this guy. Typo, semicolon, fixed. Right, it's that semicolon right here. Cool, so then this should run simple enough. We can just test it really quick here. Oop. 14, oop. Come on. Don't fail me now. And it's even. Nice. All right, you guys. That was awesome. So that was all 14 of the chapter 6 exercises. So chapter 6, at the end of chapter 6 has these exercises. Oh my gosh. That really go over some examples for you to try yourself from each of the sections of the book, of the chapter, which is really nice. And it gives you the direct reference of which section to go back and look if you're having trouble. And so we were able to complete all 14 problems today for the exercises at the end of chapter 6. And tomorrow we will go over the programming projects and complete all 12 of those tomorrow. Those ones are a little bit longer and a little bit harder as they're not as conceptual. They're actually more writing out your own code functions and putting them to the test. But this was awesome. I really enjoyed this stream so far. These answers and solutions are on my GitHub for you guys for free to get access to and reference. So, it's a really great opportunity to get some extra practice in your free time and look at my solutions. Let's go ahead and add them all. And let's go ahead and run this up. Finished chapter 6 exercises. Hit push. Nice. Let's catch up on some chats. Ray says, hey, Ray, how's it going? Welcome back in, dude. You're awesome. Always joining me here, dude. Ray, we got to talk about getting you on mod status, my boy. You're always in here day in and day out. If you want to be mod, message me on Discord, Ray. G. Anson, sorry to disturb. Where can I find this C exercise? Yeah, this is C Programming a Modern Approach, 2nd edition by K.N. King. I've got a link to the book and all of its resources in my Discord link down below for free. Or you can just kind of look online, and that's on various other resources as well. Oh, my bad. Sorry. I've been called out twice now on these indents. But it's funny. Right. That's why we have the semicolons. That's why we have the semicolons, I thought. Come on. Like, give me, if this ain't Python, we got semicolons for a reason. Let me use them. All right. Cool, you guys. Thank you guys so much for being here and hanging out with me for tonight. I really appreciate you guys joining me. And if you guys would like to continue hanging out with me tomorrow, that'd be great. I'll be back tomorrow around 7 p.m. PST to continue on with our learning. And again, thank you guys so much for being here. This was Chapter 6, Exercises from C Programming: A Modern Approach. Tomorrow we'll jump into the programming projects and continue on. Yes, Alex, some people, yeah, that book, it talked about a couple of conventions here in Chapter 5 for, here, look, we can go back and reference them here. Yeah, here, right? It talked about how some programmers even use braces and all of the time, so it really just comes down to like a preference and style. Probably, you know, through some coding guidelines instilled at your place of work, or just instilled in you personally, right? So there's a lot of these different types of formats that people prefer or whatnot. But in the end, it compiles. Right now, we gotta write clean code. Anyways, you guys, I'll see you guys tomorrow. Thanks so much for being here. Message me, and we'll continue on with our learning.